Hi, it's Robin. Today I thought we'd take a look at Jim Butterfield's book, or books, Machine Language for the Commodore 64 and Other Commodore Computers. And this is just a later edition that includes some more information about the Commodore 128. I've had both of these books for quite a while, but never read them in full, so that's what I did this month. I chose this book because it's the newer edition, but I'll probably get into this a bit more later. You may want to just go with the original book because unless you're interested in the Commodore 128 info, pretty much everything's still in here. And the Commodore 128 info isn't all that helpful. It often just tells you to refer to an extra appendix for specific information about the 128. So it's up to you. This may be the better option, but you're not missing much if you're particularly wanting to learn about the Commodore 64 machine language or programming machine language on the Commodore 64 and you happen to find a copy of this for a good price. Now, both these are available on archive.org, and there's a wealth of books on there now, so I recommend you check that out if you're interested. So today we will be looking at this book more, but I just wanted to make you aware of the original version as well. And just look at the back cover here. Pull up a chair and sit down with Jim Butterfield, the Commodore guru himself, and get the answers to all your questions about machine language. Authored by the world-renowned expert on all facets of the Commodore, this comprehensive tutorial introduces programmers of all levels to the principles of machine language, what it is, how it works, and how to program with it. With speed and versatility, you'll share in Butterfield's vast experience as you learn by doing with easy-to-follow step-by-step instructions, examples, and exercises. Yeah, not only an excellent tutorial, it's an invaluable resource you'll refer to again and again. And that's what this book is. Primarily, it is a tutorial, or basically the first half of it. Let's see here. Yeah, so 146 pages, and the entire book is what? Okay, well, there's a lot of reference at the back, especially in the second edition. But the actual text of the book, before we get to the appendices, is essentially a tutorial. Now, it's interesting that these books were published by Brady. If you followed Jim Butterfield's career, you know that he was a regular contributor to Canadian Transactor magazine that I love so much. But he's also an associate editor of Compute magazine, and it's interesting that he still got his books published with another outfit. I'm pretty interested in the story behind that, and I haven't found any time that Jim's talked about that, but if there were any interviews with him about his career, and even just how he made a living, he was on TV here for us. Obviously, he wrote for a number of computer magazines. He published some books. It'd be interesting to know, was he always just a free agent, so to speak? Was he an employee, and did he set the terms? Anyway, the things I think about, eh? So this book was published in 1986, and the original edition was in 1984. A Brady book published by Prentice Hall Press. The table of contents. So like I was saying, it very much is a tutorial. First concepts, controlling the output. Chapter 3, flags, logic, and input. 4, numbers, arithmetic, and subroutines. Chapter 5, address modes. 6, linking basic and machine language. 7, stack, the user call, interrupt, and the wedge. Chapter 8, timing, input, output, and conclusion. So 8 chapters, and there's the appendices, the instruction sets, some characteristics of Commodore machines, memory maps, character sets, exercises for alternative Commodore machines, floating point representation, uncrashing, Superma instructions, IA chip information, and the disk user's guide. He says that this book is based on an intensive 2-day course on machine language that has been presented many times over the past 5 years, he says. It'd be very interesting to learn if anybody attended one of these classes that Jim Butterfield put on. That'd be pretty amazing. I assume no video exists of them. I'd love to see that. In the preface, it is useful if you have a background in programming, and Jim stresses that you need to learn by doing, and especially in this YouTube age of people, we watch videos on things, but now I hear of some people who watch my videos, for example, who actually follow along, and that's really neat. Now, in this case, I'd recommend if you are still new to machine language that grab a copy of this book, free off of archive.org, and working through it will be very valuable. And it says that there are sort of 3 elements to learning machine language. This is the objective, but you can't get there without the next 2 items, which are machine architecture. All the machine language theory in the world will have little meaning unless the student knows such things as where a program may be placed in memory, how to print to the screen, or how to input from the keyboard. So machine language really is tied to the particular architecture. And machine language tools, the use of a simple machine language modder to read and change memory is vital to the objective of making the computer do something in machine language. Use of a simple assembler and elements of debugging are easy once you know them, but until you know them, it's hard to make the machine do anything. Remember that really holding me back in my early Commodore days until I discovered I had a Commodore 64, which doesn't have a built-in modder. And I'd read that section, the Programmer's Reference Guide, and it was useless until I managed to get a copy of Jim Butterfield's Supermon, and then that opened up all this to me. Now, advantage of the Plus4, the Commodore 128, and even the PETs is that they do have a machine language modder built in, although the one built into the PETs is extremely simple. And Jim also makes a point that this book deals primarily with machine language, not assembly language. And this is a very interesting choice that Jim's made in this book. Assembler programs are marvelous things, but they are too advanced for the beginner. I prefer to see the student forming an idea of how the bytes of the program lie within memory. After this concept is firmly fixed in mind, he or she can then look to the greater power and flexibility offered by an assembler. So that's very interesting. I guess we'll be seeing more of that later. Why learn machine language? There are 3 reasons. First, for speed. Machine language programs are fast. Second, for versatility. All other languages are limited in some way, but not machine language. Third, for comprehension. Since the computer really works in machine language only, the key to understanding how the machine operates is machine language. Is it hard? Not really. It's finicky, but not difficult. Individual machine language instructions don't do much, so we need many of them to do a job. But each instruction is simple, and anyone can understand it if he or she has the patience. Some programmers who started their careers in machine language find higher-level languages, such as BASIC, quite difficult by comparison. To them, machine language instructions are simple and precise, whereas BASIC statements seem vague and poorly defined by comparison. And when I was doing C# programming last year, how much more vague and poorly defined doing C# web development. Anyway, I'm glad that's over. First concepts. This chapter discusses the inner workings of microcomputers, computer notation, binary and hexadecimal, the 6500X's inner architecture, beginning use of a machine language modder, a computer's memory layout, first machine language commands, writing and entering a simple program. So he starts right off with bits. This is interesting to think about the bus. He gives a simple overview of how addressing works, how the one processor can speak to many different memory chips and other input-output chips. And there's not only an address bus, but also a data bus, and the ranges of what 8 bits and 16 bits can do. And he explains why we have hexadecimal, binary hexadecimal, even how to convert from hex to decimal and back again. And the 6502 treats all types of devices attached to it in the same way, whether it's RAM or ROM, or, unlike some other chips, also IA, it's an interesting acronym, Interface Adapter Chips, and he's grouped them all such as the PIA, VIA, CIA, the VIC, and the SID. I hadn't really heard them called IA in general, but of course that's always been there with the PIA, the VIA, and so on. The Commodore 64 just has the CIA chips, I believe, while it was on the PET had the PIA. Did the VIC have the VIA? The registers on the chip, how the CPU goes about with the program counter. Now, this is what's kind of unfortunate about this book. We're going to get into the first program project, C128 note. Almost every time it just has this little foreword about how you have to check Appendix E, exercises for the Commodore C128 for the correct C128 coding. That's a phrase that he uses frequently, to use the correct coding. And that isn't a way I hear anybody else speaking nowadays, but hey, Jim was there first. So the first program is just moving a few bytes in memory. It gets into what monitors are, what a machine language monitor is. Here's the display for a machine language monitor. It shows the program counter, the status register, which some monitors helpfully break out into bits. It actually doesn't mean very much when it's shown as a byte like this. The accumulator, X register, Y register, and the stack pointer. You know what? I never did know what that B star means, but it means we have reached the machine language monitor by means of a break. And that's something I was pretty ignorant about until, I don't know, even just a few years ago, I think. As the break opcode, that's a 0, can trigger a machine language monitor. Actually, it can trigger any code that you want. Machine language monitor commands, such as displaying memory, showing the registers, and the G command to go. And how you can change memory, registers, and you can run the program. So really, that's all a machine language monitor needs at its most basic. The ability to view and change memory, the ability to change the registers, and the ability to start code. And of course, the ability to be triggered in some way. And for each chapter, he asks some questions and gives some potential projects to work on. Chapter 2 is about output and using the kernel routines, the character out, that's the famous FFD2 that prints a character, get a character, FFE4, which I used far less frequently but is very important, and then this one to check for the stop key. I like how he simplifies so many things right down to the basics. Really, what more do you need than to be able to input, output, and then to be able to break out? Now, Jim was a big believer in using the operating system, and that's part of why his programs were so portable. Something like Supermon, he was able to port that very quickly to each new Commodore machine as it came out. And a lot of that was because of how he coded using the kernel input-output rather than, why not poke? Now, he doesn't say you can't poke, but he gives reasons of why it's good to use the kernel. Beyond those basics for the monitor of viewing memory, some have the assemble command. Apparently his Supermon, I didn't realize this, extends the built-in monitor of the PET to add an assemble and a disassemble command, while his Commodore 64 VIC-20 versions are self-contained because there is no basic monitor to extend. And also the disassembly, think of that as another extension to a machine language monitor, where it takes the memory and translates it, as he says, into source code. The monitor has this capability called a disassembler. He's also a big believer in linking using basic and machine language together. For example, here, even though they don't really talk to each other, he's got a basic loop that calls a machine language routine 10 times. I enjoy this perspective of 3 different ways to call subroutine calls. GoSub calls a basic subroutine from a basic program. Sys, or SYS, calls a machine language subroutine from a basic program. And JSR, jump to subroutine, calls a machine language subroutine from machine language. I never really thought of those 3. I mean, in a way it's obvious, but I didn't really think of it in that way before. Then he starts doing loops to print a string. He's printing hello here. And again, note how he's using machine language, meaning that he is not using any symbolic labels. He is assembling directly into memory, which of course isn't nearly as powerful as using assembly language, but he's right that it gives you a real feel for what's going on in memory, the one-to-one correspondence between each position in memory and what the code is in that location. How some instructions take 1, 2, or 3 bytes, and just being aware of what's going on at this lowest level. When I'm trying to teach people things, I often want to stress that you can learning is a path, and you can do things on the way that help you learn, even if that's not your final destination. A lot of people might say, well, I just want to program, like even with modern development, people don't want to learn the basics. They want to just jump right. Old man rant here. I sometimes recommend people learn a small language like Scratch. And people don't want to, they just want to learn, I want to learn Python, I want to learn C# or whatever. Well, fine. But I suggest learning as many languages as possible is best, because each one informs the other. Each one gives a different perspective. So in the Commodore 64 world, I see on Facebook lots of people say, don't bother with BASIC, what a waste, or whatever. No, I say learn BASIC and assembly language and machine language. Learn it all. Except maybe COBOL. Okay, up until this point, he's been using the cassette buffer, but he talks about how if you're trying to save to cassette, using the cassette buffer for your machine code is a bad idea. So here's a section on how to create a little basic loader where you peak memory, turn into data statements, which can then be poked back into memory. Again, you wouldn't want to do this all the time, but this is excellent understanding how this works. And again, he's always very clear about the pros and cons of each approach. But there's stuff to learn in each of these steps. And again, he sums up what we have learned. Flags, logic, and input. Now, this is an excellent chapter describing the different flags, such as here he's got this compare X and branch if not equal. So what's going on? He goes through each of the flags, the Z or the 0 flag, and I like how he basically says everyone is the 0 flag is probably misnamed and should have been called the E flag for equals. Whenever comparison is true, the Z flag will be set to on if the compared values are equal, otherwise it'll be turned off. The C flag, the carry flag, is probably misnamed too. It should have been called the greater than or equal to flag, since after comparison, the carry flag is set to on if the register is greater than or equal to. Here we go. The N, negative flag, is also probably misnamed. It should have been called the high bit flag, since numbers are positive or negative only if they are used a certain way. And actually, I really agree with this one, because the idea of negative or positive very much is up to the programmer in machine language. So, of course, the truth is that the names of these flags are fine, but they don't tell the whole story. There's multiple ways of looking at each of these flags depending on what you're doing at the time. How you think of each of these flags depends on context. But it's great that he gets into this. Okay. A little bit about signed numbers. And then he gets on with the V flag. As with the other flags, the V overflow flag is probably misnamed. It should be called the SAO, Signed Arithmetic Overflow Flag, since it is affected only by addition and subtraction commands, and is meaningful only if the numbers concerned are considered to be signed. And that's actually something I've used so little, the V flag. Some very useful information about the status register. As I was mentioning before, a lot of monitors just show it as a single hexadecimal value, but that's really not very useful. So here you can see that in the status register, which is 1 byte, how each of the flags is actually represented within that. Bit 5 is not used at all. Now, you know that you can clear carry and set carry. You can do a number of these bits individually. So, you can set that one directly, and you can set the interrupt disable flag. Some of the others you can set indirectly by loading Like if you load A with 0, then this will be set. You can also push this value. You can't directly see it, but you can push onto the stack and then pull it into the A register and then look at it or modify it, push it back onto the stack, and then pull it back into the processor stack and set any one of these you want. It's kind of a roundabout way of doing it, but it's neat that you can do that. Gives information about doing comparisons, and then logical operators, and or, exclusive or, inputting with getting, checking the stop key. What an absolutely packed out chapter, right? Next, numbers, arithmetic, subroutines. So, signed and unsigned, how you can combine multiple bytes to get very large numbers. Like with 4 bytes, you can go up to 4 billion, over 4 billion, -2 to +2 billion if it's signed. Instructions about subtracting, comparing numbers, multiplying by 2 with the shift, and using rotate and shift to do large numbers like 3-byte numbers, calling subroutines. And then he shows how to build a simple calculator here, very simple calculator, but still a very useful exercise. Chapter 5, address modes. And here he goes through, the 6502 has up to 13 address modes, and it's implied like increment X, transfer A to Y, and so on. A do nothing instruction. He gets kind of philosophical here about where the NOP should fall. What addressing mode does it follow? He describes zero page well. Something I've almost never used is zero page index, and it's interesting that it wraps around. I guess I've never tried that, but if you're at a certain address in zero page, like right near the end here, and use indexing to add a value that would bring you into the next page, it actually wraps around. And he points out that essentially that's like having negative indexing. Branching talks about these indirect jumps that the kernel uses for the interrupt sequence and many other places. Indirect indexed addressing. And like he says, a rarity, indexed indirect. That's the indexing where you add the X register and then you indirect. And yeah, like I mentioned in a recent episode, I never used that. It is interesting how Jim hardly even hints at the fact that you could just disable the kernel and BASIC and take over all of the machine zero page yourself. But again, he wasn't a fan of that. Linking BASIC and machine language. This might be a real eye-opener. It was very useful for me to see the idea that you have BASIC, the start of BASIC, SOB, the SOV, the start of variables, then the start of arrays, the end of arrays, the bottom of strings, and the top of memory. I had never seen it. I was aware that there were all these pointers in BASIC, and some of them seem to have overlapping meanings, and I think over the years, I've gradually figured most of it out, piece by piece, but I wish I had read this a lot earlier because he's broken this all down and described each area very well. And he talks about all the different pros and cons of where to put your machine language program and gives several different choices. And again, doesn't say that there's only one right way or one best way, but that there are pros and cons to each way. And he does talk about how the C64 has that 4K block at C000 49152. The wicked SOV, the start of variables pointer, it can cause many problems if it's not understood, and I've run into this before. So step by step he breaks down how to deal with that. And then this ends up being critical to being able to save properly. Oh, and more on load. You might have noticed that on the C64, if you load some machine language program and then you try to load another program, you'll get an out-of-memory error. And somewhere right in here, he describes that. Yeah, this is it here. So yeah, he talks about some pitfalls when you're trying to load. So reading this chapter will greatly increase your understanding of how BASIC and machine language can get together, how loading and saving works, some of the magic that happens there, and also how to interface with BASIC variables, how to pass data back and forth. Okay, chapter 7, about the stack. And again, he makes it very clear, like how the stack starts at the top and it points to the next free address. And this can be a confusing thing. So it makes sense that the stack pointer always points at the next free address. So lots of good information about how the stack works, if that's a mystery to you. For interrupts, it's pretty in-depth with interrupts, and how break is really like a specialized, like a software interrupt, that can be called. Different types of interrupts. The interface adapter chips. The idea of latching. This is something that if you're wanting to do VIC programming, this comes into it. And handling multiple interrupts. Okay, the wedge. And this is excellent. This is how to, it's a very simple example of how to extend BASIC. Here, adding a command. And it's not particularly useful, but he makes it so the ampersand becomes its own instruction. I think all it does is it prints out 10 asterisks. But the point here is that it's a great example of how to extend it. It's a very simple one. These are the kind of examples I like, trying to show the simplest example that illustrates the concept, and then that can be expanded on. Okay, and the final chapter, timing. He gets into how to count cycles, and he says it's often not necessary, and that's completely true. One place where it really matters is if you're doing, well, maybe game programming, but especially demo programming, where a lot of the effects that you see in a C64 demo, or any demo for that matter, rely on very precise timing, where the CPU has to hit those IA chips at precisely the right moment to get the desired effect. And that's when you are cycle counting. And on the Atari 2600, you basically can't do anything without cycle counting because of how limited that video chip is. It's like you're just constantly doing tricks to it. It is how it was designed, but yeah, that's a really, really intense. If you want a challenge, Commodore 64 programming is much, much easier than Atari 2600 programming. He also talks about input and output, using those same basic character out and get in, but how you can divert their output. Just once in a while, it's like we have a real operating system in our computers, and we can open a file and divert output to something else. And interestingly, he opens the files with BASIC, but then uses machine language. Actually, this is really smart. It gives you the flexibility and the ease in BASIC of being able to change where you're opening your file to, like what if it's on disk or printer or whatever. But then the machine language routine does the grunt work very quickly, and then BASIC closes up again. So this is a very practical reason to link the two together, to use BASIC and assembly language, the strengths of both. So he makes a simple file transfer program that basically lets you take a file from anything and send it anywhere you want. And I really like this review of the instruction set. This shows all 56 instructions, but in a very nice logical grouping, where you load A, X, or Y, you store the three, or you can compare all three. And then there's the mathematical and logical operators, the arithmetic, the shifts and the rotates, incrementing or decrementing memory or the X and Y registers. Then branching based on the 4 flags you can test for, either set or cleared. Jump stands alone. Then this family, the jump to subroutine, return from subroutine, and return from interrupt, which is very similar to the return from subroutine. And then you can set or clear these different flags. Interestingly, this makes it very clear that there is no set overflow. There is no set V. Just a strange omission from the instruction set. I suppose it wasn't very necessary. And then you can transfer between A, X, Y, and the stack register. Pushing or pulling the stack register, the strange bit command, which is used just for testing individual memory locations. It finally seems slightly useful to me. That one bewildered me for years. The no operation and the break. And that's it. That's all 56 instructions. I think I should probably make a video just focused on that, about how to debug. And then he finally talks a little bit about symbolic assemblers, like Turbo Macro Pro. Where to go? It's neat to think that he really has covered all the instructions, and those are all the elements that you need to write any Commodore 64 game or program, or well, for any of these computers. They're all made of just those instructions. Okay, and then another section. Then get into the appendices. Interesting perspective on how the opcode, the hex code for each of these, like the famous A9 for loading immediate, how this is one group where the opcodes end in these 4 digits, these digits, and so on. It's just a different perspective on the instruction set and how there is a little bit of logic to how they're arranged. I think that same chart is in the Programmer's Reference Guide. Some characteristics of Commodore machines, Appendix B. There's just some neat information here about the difference between the different PETs. The Commodore 64, the Plus 4, the B series. And then, see the Commodore 128, how much more complicated it really is compared to any of its predecessors. I still have a lot to learn about the Commodore 128. Like his comment about memory maps, to my mind, he kind of invented memory maps, or I shouldn't say invented them, he popularized them. A word about memory maps: they're always too big or too small for the use you have in mind. The beginner may feel swamped by the wealth of details. There's no threat, however. The information is there when you're ready for it. Browse through the information. It may be thought-provoking. Try reading or changing locations to see what happens. So yeah, that's why there's so much information here. He gives a memory map that's the original PET. And then the later PETs, they change things quite a bit. Then the VIC-20. And the Commodore 64 has a lot in common with the VIC-20. Some of the built-in chips. So anyway, it has memory maps for many different computers. So the reference section is quite good here. And then some disassembly of the ROMs. Jim Butterfield's famous super charts. That's excellent. I didn't even know there was a super chart in here. I really like the one that's in my complete, the Inner Space Anthology by Transactor. So these super charts are awesome because they have decimal and hex, and they show the ASCII or PETSCII representation, screen codes, what those tokens mean if they're in BASIC, that same hex byte, and the 6502 instruction. So all the different ways a byte, all the things it can mean depending on context. I love that. Exercises for alternative machines. So this is where he's written extra sections for whether you have a VIC, a PET, and here's all the C128 variations. Now, I shouldn't be so down on this. I'm glad he did this. And it probably makes sense to keep the main text clean for the Commodore 64, and then the 128 is a bonus. Floating point representation. We briefly got into that a few episodes ago, how the exponent, how we incremented the exponent, that multiply it by 2. I should do an episode about floating points sometime. I like this uncrashing. We've talked before about reset switches. So he talks about how to do that. +4, there's another good thing about the +4. There's not many, but that has a reset button built into it. A great section all about Supermon. You can type in Supermon if you want. So the interface adapter chip information. So that's a useful reference. I don't think he wrote any of this. I think this is just he got it from the manufacturers and reprinted it, because a lot of this looks very familiar to me from the programmer's reference guides and so on. But still useful to have it here. Vic2. Yeah, this is all right out of the programmer's reference guide. The mobs, the alternate name for sprites. A big SID section. This disk user's guide, there's this optional disk that has a bunch of cool stuff on it, such as Supermon. I've never seen Supermon for some of these machines. His program Unicopy for copying files. Jim Butterfield started the whole piracy thing. Okay. And then just a glossary and a pretty good index. Okay, so that's it for our tour through the book. Hope you find that useful. Just want to bring some of these things to your attention. I found this a very good read, and I just want to encourage you to read some of these books that I've been looking at. There's a lot to learn, and that's a lot of how I've learned what I've learned. I've learned a lot from books. So I just want to encourage you to look into these books, especially since they're just available. They're on archive.org for free nowadays. Or of course, try and pick up a paper copy if you can. I really love having the real book. Read them at bedtime. good bedtime reading. Only get through like a page or two and I'm ready to sleep. But I do find it interesting. Okay, thanks for watching. Thanks for your support, and we'll talk to you next time.